Hello Internet, today is a special day. Quadro 8000. This one's got Samsung 12 chips on the back, 12 chips at the front. This one's a 325BM HC14, 48 gig. Each one of these chip is 2 gigabytes. So I already did check briefly for short on everywhere where I could look, with the exception of the 12 volts coming in. So nothing here. It's looking good. Am I getting the right reading? Okay, so this is ground. I'm not reading any shorts. Okay, through this, let's power this thing on, see what it does. So one goes here, another one's gonna go into here. See what this thing is doing once it gets powered. And it's pulling very little, if anything at all. So let's see if we can fix this thing without taking it apart. Can we do this? Most likely, we'll see. Let's, but though, I think it was taken apart already. So let's start looking around. This thing does not have a back plate, so that's number one reason why these things break. I am guessing we're missing 1.8 volts somewhere on the board. As a matter of fact, we can probably check any of these capacitors and see if we're actually getting 1.8 volt on any of them. So let's see. Let me go flip the switch. Nothing here. Oh, I actually do get 1.8. Okay, so we're missing something else. We're missing the core. Since we have 1.8, so the problem is likely around the core then. Okay, let's have a look around the core. The core PWM controller, or just look everywhere. Scanning the board for a single knocked off component of some sort, some kind of a scratch. Sometimes it's very difficult to detect minor issues. So I think this is our, what is this, MPS what? 2888. So this is an 8-phase PWM, so this could be the core. And I don't see anything that's knocked off, so we might have to take this thing apart after all. But we're gonna continue on looking around. Maybe some feedback resistors got knocked off or something, who knows. Maybe these be something over here. Just looking everywhere we can. We're looking for any kind of scratch, any kind of dent, anything that could point us to the right direction of where to look. And I do not see anything. Unless I'm missing something, everything is looking good to me. I don't see anything knocked off, so I guess we don't have a choice but to take this thing apart. So looks like it's not gonna be easy pizza for us today, and no miracles today. Fortunately, we're gonna have to take it apart. So let's do that and see what we can find. Interesting. So these pads apparently go here. Whoever took it apart, please don't take things apart anymore, because you are creating problems. All right, so let's that over here. I'm guessing that's for these guys here. So everything else is looking okay-ish. The bottom 4 chips are under compound. Thank you, Nvidia, for doing such a great job making this graphics card less repairable with every drop of your epoxy or whatever it is that you use. We all greatly appreciate your effort making your graphics card less and less repairable. Take that away. Let's verify some fundamental things, such as this coil here. Memory is good. We had 1.8 somewhere this pack. 1.8 good. No short. So we got 5. We have 1.8. What is it that we do not have? No idea. Let's remove the goggles. Core measures 0.122. So that's normal measurement, at least in theory. It is not short. I guess I'm missing the core, but why? Could be a bad controller, could be bad customer. Depends on what they did to this card. So from what I've seen already, it had been taken apart. So it could be the customer, because I did not see any damage on the back. But that doesn't mean there's no damage on the back. There could still be damage on the back. I just didn't see it. So, but once we start investigating, we might turn back to the back and actually find the root cause of the customer. Who knows? Okay, let's power the back up again. See what we're missing. Here's our meter. Sharpen probe. All right, probe is as sharp as a needle. All right, let's see. So what do we have? We got 5. 12 here. That's good. Nothing here. So this is USB-C. 12 here, 12 here, and 12. Perfect. Okay, so 12 here. Pack. Nothing. 1.8. Yep, 1.8 there. So basically no core, right? So no core. And where the core is coming from, that's a very good question. So I'm guessing the core is on the back. All right, what do we want to start? Well, since it had been taken apart, might as well start looking around, looking for trouble anywhere, pretty much. So I'm gonna go take a quick look around, see if I can find anything. Actually, you know what? Let's take a shortcut and remove the goggles. Yeah, there we go. We got something glowing. Something is definitely glowing here. Flip the board. Just don't know which side it's glowing on. I think it's... Ooh, it's glowing here. Holy cow. This chip here, whatever this chip is. See this? What is this? Why is it glowing? Somewhere over here. Oh, this, I don't know what this is. Take the board. I have no idea what it could be. Could be a logic chip. Who knows? All right, so what I want to do, let's go over, have a look at chip here. What is this chip here? This guy. This guy is glowing. So do we have a short on this chip? So we got a short here.
One tiny issue.
Nothing here, short here. So I don't know what this chip is and why it's shorted. So, but I'm guessing this is the input.
It's a major issue.
I wonder if this is one of them PEX reset chip that's oversized for some reason. So let's go into reset here. If we make that, no, we do not. So we're not making the connection from here to there, which means I do not know what this is. I'm gonna have to figure this out, or maybe find something on a donor board. All right, so a totally random board view for a 2080 Ti. This is some sort of a 5-volt ground. Yeah, I knew that was. What's in here? 5 volts. So it's wait, why? Oh, okay. So we do have 5 volt, but the chip is short. Very interesting. Which means the 5-volt buck converter is working extra hard. Now, is that true? That must be true. Let's look at the 5-volt buck converter, the thermal camera, one more time. So if this thing is short, the 5-volt buck converter is probably running really warm. It's supposed to be right here. Turn that on. Not necessarily. So I'm guessing it's getting 5 volts somewhere else. What's in here? I don't know. Who cares? Well, whatever this thing is, let's take it out, see what it does. I'm not exactly sure what that chip is. It's probably it could be a steering chip, who knows. You know, the chip that's steering, literally steering load from one MOSFET to another, regulating the load in between the two. So that could be it. I don't know. So let's remove this guy. Hopefully we can find one on a donor board somewhere, so we won't have to order this thing and wait for a week for it to arrive. Get this thing done before Christmas. All right, there we go. Come on, there we go. Come on, almost there. All right, the chip is out.
So right now what we're gonna do is use a good working donor board.
Okay, looks like I found one here. This is EVGA of some sort. It's got to be the same chip, whatever this chip is. If you guys know what this chip is,
Leave it down in the comments.
it's probably on the board view. I'm glad I didn't throw this thing away. This thing has been sitting in my pile of junk for quite a bit by now. So let's take it out. Oh, look at the worms. Ew, get away. The EVGA worm.
Bummer.
Now let's solder that thing back onto our board right there. Hopefully that thing in the middle is not a hole. No, it's not. It was just some kind of dirty spot or whatever. There we go. That looks beautiful. The black horse flux.
The best flux. I'll be back in a minute.
Let's quickly check for a short. And the
Short is gone.
all right, this is ground. We're good. No more short.
And remove the goggles.
Perfect. See how easy this is? Super easy to clean. I like this flux. Cleans very easy. Very critical when I'm doing like small crack repairs. Cleaning is extremely important. Okay, so I'm gonna put this thing into the exhaust tube, cool it down, and I think we have a fix. Unless there are some secondary problems, but I don't know. The more problems this thing has, the more interesting the video will be. Not like we're missing anything out. I think that should be enough. Not particularly cold, but not particularly hot either. Alright, let's see what happens when we power it on right now. Well, first, I want to make sure that nothing's getting hot on this end, even though the board is a little bit warm.
Power supply is on. Nothing smoked.
So it's not getting hot now that I can see. But this chip here is getting hot. So if we were to look closer at this guy here, I think, see, there we go. I don't know what this chip is. It's probably the UP7561Q. So that could be a steering chip. I don't know. Or this one here's a steering chip. I don't know. So, but we still have no power, whatever. So we should be getting 5 volt on this chip. So let's start digging around this chip. See if we have all the voltages that we need. There's our chip. Okay, let's start probing for voltages. Do we have 5 volt?
We got 5 volts.
In here, 0.4. What does that 0.4 translate to? I have no idea. All right, so it looks like this thing here is a USB switch. We don't care about that. But what about the chip that's at the front? What is this chip? This chip is probably that steering chip. I don't know. Right there. It could be the steering chip. Let's switch over to the board view so we can figure this out. So that chip is here. Yep, that's a steering chip. So I don't see it being particularly hot. I'm guessing it operates these two MOSFETs.
I don't know how.
See it right there, goes to the gate, and then it's driving these two, and I'm guessing it's probably driving these two as well. Yep, right there. Usually this controls two pairs of the MOSFETs, and then they're just gonna switch in 12 volt from one pair of MOSFETs to another pair of MOSFETs. I don't know why they do it, but whatever. All right, so that works. We got that fixed. We still have 1.8. We got 5, but
We still have 6 beeps.
what is this here? That's a memory. The core is probably this guy here. Let's
Remove the goggles.
and see what kind of stuff are we getting. All right, so let's go look at the core controller, PVM, whatever. Maybe we can see what the markings are, MPS, whatever. And let's start poking around. We're looking for some kind of a enable signal, maybe voltage in. Let's see if we have voltage in. That would be BVM ID. No, that's not it. I need, it's usually hidden by the OP something something. I think it's this guy here. Resistor 0 ohm going into the 5 volt somewhere eventually. Yep, so we should be getting 5 volt here. That's gonna be our VCC for this chip. So let's go. 1, 2, 3. They conveniently placed the test pad here, and we get 0 volt. Do we have a short? No short. Okay, so 0 volt here.
Bummer.
Why is that? Let's start backing down. I'm guessing since we had a short and 5 volt on that chip, something along the lines of either this or something here or something here. So either this resistor died or this one. So let's go and
And remove the goggles.
okay, so we don't even have a resistor here, but we have this one. Is this reading 0 ohm? It's reading 0 ohm. Are we reading 5 volt before and after? Let me switch the lighting here. Nothing here, nothing here, nothing here. So there's nothing anywhere. We do get 5 volt here, but nothing here. So if we had a 0 ohm resistor here, we would be getting VCC, but we don't, which means
No fix.
that is broken somewhere else. Let's go and hunt down. Let's go. What is this resistor here? 8.2K going to the ground. We don't care about this one. So something is still connected to here. So let's jump around. So there's a lone resistor, a 2K resistor, 28K. Not likely what we need. So this one's not there. This one's grounded. This one is, yeah. And then this one is very interesting. Well, this isn't, you would, obviously this isn't the correct board view for this card, obviously, but so we're gonna have to be digging around. Possibly that this 28K resistor at the front of the board got blown. I don't know. Let's have a look. I highly doubt it, but who knows. We're at the front of the board now, and we're looking at this cluster of nightmare. Maybe we can find something broken in here, though. I don't know. 5 volt. All right, let's try to figure out where that resistor is supposed to be. So it's supposed to be where the hole is, and slightly up here. So we got a couple of diodes. So this diode, and it's supposed to be to the left of this diode. So it's supposed to be this pin here, but there's nothing. There's nothing. We're reading 3.3. Wait a minute. Nope, here. It's supposed to be here. Yeah, and there's nothing here. So if there's nothing here, where else does it go? I don't know. And we're not reading any kind of short. What are we reading here? We're reading 8K. And when it's powered, same 8K. So we're losing 5 volts somewhere. I guess we could just solder that one resistor there and call it quits. So that's going to... Wait, what is that? Somebody had been poking around here. What is this diode here? 3.3, 0. Somebody had been poking around here for whatever reason. This diode looks suspicious. I don't know, we'll look at it later. And that diode would be what? Over temperature protection. All right, let's go into here. So the 5 volt is here, right? Where does 5 volt go? 5 volt. So we got a 5 volt. Now that's a USB switch. We don't need that. Okay, wait a minute. If this 5 volt is the USB, what is this? Oh, that's another USB, okay. Just the way that they label these. USB switch 1, USB switch 2. So this is the main one, okay. Well, since we do have power good, we will be having 1.8 voltage in, but where does that go? So we got 5 volt, it goes into here. It's almost like it's not going anywhere. If I look at the net, see? If you look at this board view, it doesn't seem to go anywhere. That's just so weird, it's just like circulating. What about the board itself? Looks like as if the 5 volts coming out of here and it goes back into here and it doesn't go anywhere else, which makes no sense whatsoever. Why? And then this one, this is the USB-C, so we're not gonna have... Do we have 5 volt on both ends of the coil? Or just one? Oh, we got 5 volts on both ends, okay. And we got power good in here, yes, 3.3. What's in here? That's supposed to be ground. No? Whatever. Very interesting. I do not understand why. So, do we have 5 volt coming into the driver MOSFETs? Let's see if we can figure this out. Let's go desktop. So, first driver MOSFET. Let's see. T-mon. Driver on. So, driver on is usually 5 volt. Or the VCC is 5 volt. So, if we were to look at this driver MOSFET VCC pin number 4, which would be 1, 2, 3, 4 on this capacitor here, we got 5 volt. So the 5 volt is definitely coming in to the board, and the driver on would be 1, 2, 3, 4, 5, 6 pins from the bottom. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 pin, and the driver on is 5 volt. So we're getting 5 volt everywhere, with the exception of our controller. How is that possible? I have no idea.
Everything works except no image on the screen.
Should I just run a 0-ohm jumper there and call it quits? I mean, if we're getting 5 volt all the way across to this chip that had been shorted, right? So why isn't it not on this end of the board, which isn't even miles away from the 5 volt rail? That is beyond me. And we don't read a short here. So I don't know. We could just run a 0-ohm here and see if that helps. I could sit here all day trying to figure this out, where it comes from what. And the board view doesn't seem to match.
All that talk for nothing.
So I guess we can just throw in a 0-ohm there and see what happens. If it blows up, then...
Customer is watching, he's gonna be as excited as I am probably.
It was dead when I got it. Okay, let's some magic flux in here, and let's bring in the 0-ohm resistor and make a pathetic attempt of soldering it on without preheating the board, which almost never works. So let's preheat the board. There we go. The resistor is in. I am still baffled by why we don't have 5 volt here. We should, but we don't. Yeah, very strange. All right, let's see what the card will be doing now. Let's go ahead and quickly remove the goggles, cool it down just a little bit. All right, and let's have a look at this thing, see what it does. Yeah, we're still reading 0. This guy here is warming up. I don't know what this is. What is this? Another one of them chips that could be responsible for something. I don't know. Let's go over to our desktop, see what this chip is. Okay, that's a memory. So if this chip is warming up when we power the board, that indicates that there's voltage on that chip, nothing else. But does the other chip that we just ran the 0-ohm resistor to is warming up as well? Yes, it does. Look at that. So the chip is now warming up, but we
Still have 6 beeps.
0.5 amp. Still no power. See? That's just weird. We could jump around the logic chips and see if any of them are giving us any kind of signs of trouble. But let's go over to the controller, see what we want to check in here. So I want to check, obviously power good's not going to be there. And the enable 1, 2, 3, 4, 5th pin from the bottom is going to be 1, 2, 3, 4, 1, 2, 3, 4, 5. It's going to be this guy here to make it easier to test. Scrape away that mask here. All right, that's going to be my enable pin test. Do we have enable? No. And the enable, there's no enable. But we do get 5 volt now, so no enable, so the chip isn't enabled. and the enable comes from the chip itself, and it's not being pulled low. So what else is going on? No idea. Maybe we can
remove the goggles.
kind of run around the board and see if we have
The goggles.
12 volts everywhere, you know, things like that. 3.3 here, still got 5 volt there. This shunt here, this shunt here, 1.8, whatever this is. Very interesting. The core has no voltage. Why not? Yeah, nothing. 1.8. So let's look at 1.8 one more time. Not one more time. We haven't looked at it before. And I want to see if, well, for one, I haven't completed the visual inspection, which I probably should. Don't know why I didn't. I want to see if we have
The goggles.
on this thing. So let's see. That's gonna be
Oh, hey.
power good pin number 1. Very first pin. Okay, pin number 1. We have a test pad here. Good. We have power good. So we have 1.8. We got 5.
But we still have 6 beeps.
Let's do some more visual inspection, I guess. Maybe we find a cut trace. Maybe we can revisit the back of the board and do some more close-up inspection there. Because I got a feeling that something is missing somewhere.
It's personal now.
And that 0-ohm resistor that we soldered doesn't need to be here, though. This one diode here is kind of weird. It looked like somebody tried to poke it. I don't know. It looks like this pad here had been poked with something, or maybe not. Maybe it was just solder. Who knows? But this here looks weird. Doesn't look like it's soldered properly. But it looks factory though. I don't know. It's 12 volt here. Nothing's gonna be on this side of the driver MOSFETs, I don't think. What is this logic here? This logic is okay, 5 volt power good. So we're gonna have 5 volt power good here. Check. Driver on, check. VCC, check. Output, check. The output would be to turn the drivers on. Okay, so that one's working fine. What other logic that we can test to see if there's any trouble? Text enable. Let's see if we can kind of scroll around here for any kind of logic chips. So NVVDD enable. Well, we're not gonna have that because we don't have that on the chip. So yeah, that's not gonna be there. And we can even look. We're not gonna have any of that. I don't think, but we shouldn't. So that would be. It doesn't. Oh, it would be here. Yeah. Yeah. There's nothing there. Oh, we're reading 60 ohms. Okay, so something is pulling the signal low. Okay, that's interesting. What about the other signal? Nothing here as well. This one's also pulled low. What about here? 3.3 and obviously no output. What is this? What about here? What's in here? Low, low. This one's good. So this one's 69 ohms. This one's open. So we're doing 69 ohms. And once we turn off the device, the resistance is rising to 21K. Okay, so what does that mean? That means something is pulling this. Wait, is this correct? Yes. Something is pulling this and this signal, which are the NVVDD enable and power good. It pulls it low, as well as this signal here. Well, that's the same signal, yeah. Probably routed through a 0-ohm resistor. Correct. So that signal is routed through a 0-ohm resistor into here somehow. Okay, so could it be... No, it's not gonna be this diode. It could be this transistor here. It's another logic to check. Let's see if we can scroll up and check this diode, this transistor here, this U gate. So let's power it on. Immediately we're pulling low down to 68 ohms, which means, do we have voltage here? Yes. Do we have voltage here? No. Do we have voltage here? Yes. So we're missing voltage here. What is this voltage? Let's switch over, click in here, and this is NVVDD enable prot. So it, after all this mess, it could actually be this diode. So let's replace this diode. Let's check the diode, see if it works. All right, so let's see, what do we get here? Voltage drop, quite significant, almost open line. Same thing here. If we reverse, 0.3, 0.3, 2.3, 2.4. What about if we compare these readings on a donor board? It's gonna be this guy here. So 2.4, 2. Yep, readings are definitely different. 3. The readings are definitely different. All right, but then we're measuring in circuit, so who knows? All right, let's remove this guy. Where is it? There. D1. Now the D1, wait a minute. Well, how could I have missed this? D1 is actually, it's like a protection diode. So it protects from
6 beeps.
overheating. Yeah, so that's like an over temperature diode protection. So we could have a faulty driver MOSFET that's protecting the board or giving us a false reading of being overheated. Hard to say. So to rule that out, we can just simply remove the
Goggles.
diode from the board, and theoretically it should power on with protection disabled. But this diode looks kind of funky. I don't know. I just want to replace it. All right, there we go. Diode is out. See if we can prep the pads. There we go. A little bit of flux to hold the part in place. There we go. The diode is in. So if this doesn't help, we're gonna remove
The goggles.
and see if we can power the board without it. And my best guess, it's going to power on. But in this case, we are disabling the thermal protection, which is basically protecting
The customer.
from burning a hole from a shorted driver MOSFET. Sometimes these driver MOSFETs can give out false positive, and finding it would be time consuming. We will have to, if the board allows, we will have to disconnect the temperature sensing resistor from the temperature sensing circuit from every individual driver MOSFET until we stumble on one, basically with the diode in place. If it still doesn't work with the diode soldered, we're going to be removing resistors from each or several at a time driver MOSFETs. And if it does power, then it's that one driver MOSFET that's reporting a bad value, so we'll have to replace that. But I don't know. Let's see what the board is doing now, if it's any better. Oh, same thing. Okay, still
6 beeps.
all right. Let's remove this diode and see if the board will power, so we can figure out which of the driver MOSFETs are bad, if that's what the issue is. It might not even do anything, so who knows? You just never know. Let's cool it down. Okay, I think the board has cooled down enough. Let's power it on, see what it does. Still nothing. So, disabling the protection with the removal of a diode did us nothing. Okay, let's solder that diode back in. No, it's just wasting our time here. Okay, so if the diode had no effect, so that means driver MOSFETs are probably okay, and we're having a problem with the circuit somewhere else rather than this thing here, which is annoying to say the least. Okay, let's dig in. Let's dig in further. Let's go back to desktop again. So we were missing this signal here. Let's poke around, see where it leads. So it leads here, it leads here. The diode at which it's pointing at is not on the board. So then we get 10K resistor there, and then the chip itself. Okay, let's look on the back of the board. Some kind of a 10K resistor, some sort of a pull-up up to 3.3 volt. That's supposed to enable something. Let's have a look at the back of the board. So this is the thing. This board looks a little different, quite a bit different, actually. Okay, so I don't know where that resistor is. Let's look at the bottom, because according to, see, if I look on the board view, I don't know where this resistor is. It's just not there, and it's not there on the EVGA variant either. So whatever. Where does it go? So we can probably trace it out. So it goes here. See if there's any 0-ohm resistors or something like that. What do you do? 10K. What is this? 10K. Not gonna happen. So let's look down. So it could be here somewhere. So let's look at the bottom and see if we can figure this out. All right, here somewhere. So maybe we have damage here or something. So that signal could be
Oh, hey.
on top of this diode. And let's see what kind of readings are we gonna get. So what's on this diode here? Nothing. And if I'm not mistaken, we should have 3.3 volt here. So we're missing 3.3 volt here somehow. We do have 3.3 volt here, don't we? Yeah. Before and after? Yes. What about this resistor here? That's 12 volt. So it looks like we're missing 3.3 volts somewhere. So let's start chasing the origin of this thing. So what is the origin of this 3.3 volt? Who knows? Looks like it's the auxiliary. So on the 30 series cards, this one's called 3.3 AUX, whereas on 20 series it's NV3V3, if I'm not mistaken. At least that's what it shows here on the screen. So whatever. Let's go and find this chip. And this chip is this guy here. This little tiny little guy. So let's check if this thing if it generates 3.3 volt. And it does not. Does it have, this is ground, most likely. Do we have VCC 3.5? It's probably enable and 5. So VCC and the enable, but nothing on the output. Let's check the output for short. We're reading short on 3.3 volt. Okay, finally. That's the auxiliary 3.3 volt that is short. So before we go too crazy, let's go ahead and remove this 0-ohm resistor. And we're going to inject into that 3.3 volt thingy here. Or we can just remove the goggles, look at it under a microscope and see if it warms up. But I don't know. Let's remove it. I want to remove it and see if the short is gone. If the short is not gone, or what's the easiest thing to do? No, the easiest thing to do would be to remove the goggles. That's right. Let's do the easy stuff. Let's do the easy, lazy stuff and remove the goggles. Inject 1 volt into this thing. See what happens. So we should be injecting here. And here goes 1 volt. And the chip is hot. Let's do it again. Hopefully you can see this right there. It's the chip. Son of a diddly. Alright, whatever. Let's replace this chip. See if we find one on the donor board. Yep, there's one right there. There's one right there. So let's go and remove this one. Alright, let's see if that helps. I'm guessing it will. I can fire up the thermal camera and see if the board lights up. And the board lights up. See right there, 2 amps. Almost. I think we have a fix. Let's boot the board or boot the card. See if it posts. My guess, we are done. Probably gonna run a memory test just to make sure that there are no memory errors anywhere on the card. No HDMI. Alright, display port it is. The HDMI port would cost too much money, so they ended up going with the display port. See, because the thing is, every time any manufacturer is using HDMI, they have to pay like a royalty or something, because it's copyrighted or trademarked or whatever. So, but display port isn't. Alright, hopefully it's all nice and clean. Looks good so far. Alright, we got a pass.
And remove the goggles.
I'll go ahead
And remove the goggles.
put it together, run some tests, make sure that it works okay. Probably put some new pads on there to make it happy for a little while until they dry out. And thanks for watching. Hopefully this was educating. Hopefully it was fun to
Remove the goggles.
go on the journey of looking for a little tiny part that you probably can't even see on the screen. So tiny. Regardless, that will be it for this repair. Don't forget to like and subscribe, and I'll
Remove the goggles.
see you later. Goodbye. Alright, here's the thing. Here's what I see. First, I see some weird marks on the core. I don't know if you can see this, like right here. Scratches and scrapes. And I also see that same thing on the cooler. And my worry is that the vapor chamber is busted. Because if we look at the vapor chamber, you can see that something is here and it looks like holes. And I don't know the origin of this, but I think we have a busted vapor chamber. This stuff is this is paste that had been caked on. See, it's kind of flaking away. I cannot even dissolve this paste, it's so hard. But I think we have a number of holes on that vapor chamber. I don't know, man. If the vapor chamber actually works, I would be surprised for sure. These are not little tiny holes by any stretch of imagination. See if I can polish this out. Yeah, it does not look good. It looks like some real holes here. So in this case, if the vapor chamber is failed, this guy's gonna have to get himself some sort of a blower edition of sort. So For that reason, I'm not going to put any pads on the memory right now, so don't want to be wasting the memory pads on the cooler. That's not even going to cool anything. So let's try to run it the way it is and see if the temperature is going to creep up gradually and all the way up to 100 degrees. And if they do, then there's nothing I can do. I'm not even going to do all the screws, just enough to test it. All right, here we go. Slowly getting up, getting up, getting up, getting up, getting up, getting up. The fan is blowing and the fan is providing very little to no cooling whatsoever. And we are starting to throttle almost. Yep, vapor chamber is a bust, unfortunately. So let's shut this thing down before it overheats. So that's it. That will be it for this repair. Unfortunately, nothing I can do with busted vapor chamber. And I do not have any coolers that would fit this card either way. So that would be it. Set day. The card is fixed, but the vapor chamber is a bust. It is what it is. Goodbye.